Okay, continuing, we are looking at the structure of the MAC address, Ethernet MAC address, and we had introduced the OUI and the vendor assigned value. The Ethernet MAC address needs to be unique. What makes it unique? Every vendor, every manufacturer anogadzira these devices anokwanisa kuassigna that MAC address. But how do the organizations responsible make this address unique? Kana munhu wese anokwanisa kugadzira achigadzira oassigna that value oassigna the MAC address. Chii chinozoita kuti ave unique sei asingafanani? So we have what we call the OUI, which is 3 bytes, 3 times 8, 24 bits, 24 bits assigned by the IEEE to the manufacturer. So this IEEE organization assigns a value to the manufacturer, which is unique, right? That's one. From there, the manufacturer itself also assigns these values, which is also unique to the manufacturer. So at the end of the day, all MAC addresses of all devices are unique. Why? Because this half is unique from the IEEE. This half is unique from the vendor itself. And basically that makes up the structure of the MAC address. So in a baby MAC address, where are all those hexadecimal values coming from? Some are coming from IEEE, some are coming from the manufacturer of the devices that we're using. So laptop yangu it's a Dell. It means the MAC address on this Dell laptop, which is on the NIC, this half yakabva ku-IEEE, this half yakabva ku-Dell, is the Dell who assigned that value. Right. Frame processing. Now we're getting into the interesting stuff of when we're talking of switching. When a device is forwarding a message to an Ethernet network, the Ethernet header includes a source and a destination MAC address. When the NIC receives an Ethernet frame, it examines the destination MAC address to see if it matches the physical MAC address that is stored in the RAM. If there is no match, the device discards the frame. If there is a match, it passes the frame up the OSI layers where the encapsulation process takes place. Any device that is the source or destination of an Ethernet frame will have an Ethernet NIC and therefore a MAC address. This includes workstations, servers, printers, mobile devices, and routers. To break it down, there is nothing much to break down. When we are forwarding a message, we have the source and the destination. Starting with the year, if I'm to break that down, every device that has an NIC, it has a MAC address. So our devices that we are using here to communicate, they definitely have an NIC that allows those devices to communicate with the network. Therefore, they have a MAC address. Given that every device has a MAC address, when we are forwarding frames, in the frame we have the destination and the source. The source where the frame is coming from, the destination where the frame is going. If I take this small network, for example, if I'm sending from PC number 1, which is AAA, that's the source, to PC number 2, this is not address, this is mine, to PC number 3, which is CCC, this destination MAC. So I'm sending from this PC to this. Right. This one will discard, this one will discard, the frame will be sent to this PC. At this stage, why is it not being forwarded directly here? It's probably because the MAC addressing table is empty. this switch does not have a MAC addressing table. So this switch does not know this is CCCC. So when this device sends to this switch, the switch broadcasts first, and when it broadcasts, this will receive, this will receive, this will receive. This one will drop because when it opens the frame, it will see the MAC address of that frame is the destination MAC address is not the same as the MAC address which is on this PC. Therefore, it drops. This one as well, it drops. But this one, since there is a match, it will take that frame and push it to the upper layers. It goes to the network layer, it goes to the transport, it goes up to the application, and we can see the message that we have sent from the application layer. Basic breakdown of that frame processing. Let's continue with more. Unicast MAC address. In Ethernet, different MAC addresses are used for layer 2 unicast, broadcast, and multicast communications. We already defined what unicast is, sending to one device. That is unicast, right? If I talk of broadcast, I'm sending to all devices on the same network segment. On the same network segment, we will learn about the router by default not broadcasting frames. We'll learn about that. So on the same network segment, we can broadcast, leading us to have those three different types of addresses. If I'm sending a unicast, I have a specific address that I'm sending to. If I'm sending a broadcast, am I sending to, for example, if I take this one, if I'm sending a unicast to one device, let's say this one, this is device A, it means with my destination MAC, I just have device A, the MAC address A as the destination MAC, no problem. If I want to send a broadcast, it means I'll need to send to A, B, C, D, and E. So in the destination MAC, the field with the destination MAC, what's the destination MAC address am I supposed to have? Am I supposed to send one by one up until I get to all these devices? No, that's not how it works. So we have a different type of address, which is called a broadcast address. And the broadcast address is FFFF. FF, FF, up until we get to 48 bits. That's a broadcast address. With IPv4 addressing, all ones, we'll learn about a broadcast being all ones in the network. Right. If I'm sending a broadcast, it's the same thing. We create a group and there is a specific address that I put in this field, the destination MAC. There's a specific special address that I put there, which allows me to send to a group of devices. Not many devices, but not all. So it's very important to grasp that concept at this stage. If I'm sending to one device, I have one address in the MAC, in the destination MAC field of the frame. This field, where is it? This field right here. So if I'm sending to one device, I have this, a unicast, no problem. If I'm sending to a broadcast, here, this will be different. There will be OFs here. If I'm sending a multicast, this value will also be different. You won't have many values since you are sending to many devices. You won't have many destination MAC addresses. You only have one. Right. A unicast MAC address is unique. That is used when a frame is sent from a single transmitting device. Okay. The process that a source host uses to determine the destination MAC associated with an IPv4 is known as ARP. We already introduced ARP, Address Resolution Protocol. If you have an IP address and you want to know the MAC address of that given IP address, you use the address resolution protocol. And if you have an IPv6 address and you want to find the MAC address corresponding to that IPv6 address, we have what we call neighbor discovery. We'll discuss those with time. The source MAC address must always be unicast. The source is always unicast. You send from one device. It's logic that the source is always unicast. Broadcast, I think I already spoke on this. As you can see, the destination MAC is FFF. You will definitely get a question. If I'm sending a broadcast, what will be the MAC address? It's FFF or Fs. Right. What differs as well? If you're sending a broadcast, it also means in the packet, the destination IP address, it also needs to be broadcast because you're sending a broadcast. With this one, we had 200, 192.168.1.200. Probably our network, I'm going a bit deep, but those who can follow, you can follow. Probably our network was like this. This is our network, 10. Let's call it 24. That was our network. So with the unicast, I can have 192.168.200. That was the unicast address in the previous slide. No problem. But with broadcast, it's now 255. Why is it 255? It's because 255 is all ones. If I have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Right, this is 255. That defines what a broadcast is. So in this network, if I'm to have a broadcast, if I'm to send a broadcast, this host portion will need to be all ones. That's why we have 255. That's why we have 255 here. That is what we call a broadcast address. So with MAC is FF, with the IP address, all ones on the host portion of the address. Multicast. Multicast is a bit tricky. Okay, with MAC addressing as well as with IPv4 addressing. Right? With MAC addressing, if you see this value right here, it means we have a group of addresses, a multicast, a group of addresses that we are sending a frame to, right? If an address is this is the prefix, it means that is a multicast address. If you just see these numbers, it means it's a multicast. I cannot repeat this enough. Those questions, those are the typical questions that you get in the exams. You are just given an address with these numbers. And the answer that is expected of you goes with understanding that if you see these numbers, there is a multicast somewhere. That's all you need to know. If you know there's a multicast somewhere, it becomes very easy for you to find the answer out of a given choice of answers. Right, there's a destination MAC of this when the encapsulated data is an IPv4 multicast packet, and a destination MAC address of 333 when the encapsulated data is an IPv6 multicast packet. So it's different. If it's IPv4, then we have this. If it's IPv6, we have this. There are other reserved multicast destination MAC addresses for when the encapsulated data is not IP, such as STP. So if the data that we have is STP, for example, it's not IP, then this value is different. So if you see this value, it means the encapsulated data is IPv4. If you see this, the encapsulated data is IPv6. I don't know about STP, but you definitely see a different value from these two that we have here. Right, it is flooded out all Ethernet switch ports except the incoming port, unless the switch is configured for multicast snooping. It is not forwarded by a router unless the router is configured to route multicast packets. Right. There's a lot of information loaded here. We said if I want to send to one device, let's say our MAC addressing table, it has all these addresses. So it means if I want to send a unicast to this device, it will go to that device. If the address is in the MAC addressing table, no problem. We get that. If I want to send a broadcast, then I'll send to all devices. We understand the broadcast. We are sending to all devices, not a problem. But there is some confusion. If I want to send a multicast, instead of sending only to these devices, because we know there's a group there, a multicast, we are sending to a group of devices, but not all. What the switch does, by default, it does not understand what a multicast is. It just broadcasts. So it will broadcast everything, but the devices which are not defined in the multicast group, they will drop the packets. Very important to understand that. So in multicast, we still broadcast the frames. In broadcast, we broadcast the frames as well. The difference is with the broadcast, all the frames, they are accepted by the destination devices. But with the multicast, devices that are not in the group, they reject those frames. However, technology may improve. However, we now have what we call multicast snooping. And with multicast snooping, we have a switch which can be configured to learn which ports have devices that are subscribed to a particular group. So basically what snooping is, you come and configure this switch so that it knows at this port, this port, this port, those three ports, they belong to a group. So now, if we have configured snooping, if a multicast frame is sent there, it only goes to these three devices. Without multicast snooping, it's a broadcast. And the problem is, this is a waste of resources. This is the waste of CPU, the processing power of our switch. It will be much wasted because it is forwarding frames to non-recipients. Right. Because multicast addresses represent a group of addresses, sometimes called a host group, they can only be used as the destination packet. The source will always be used. The source will always be a unicast address. What is this? Because the multicast addresses represent a group of addresses, okay, they can only be used as the destination of a packet. Okay. As with the unicast and broadcast addresses, the multicast IP address requires a corresponding multicast MAC address. Right. We have seen kuti multicast MAC address yakaita sei. If this one, for example, that is an IPv4 multicast MAC address because it starts with these values. Kunok as well, you need to know there is a range of IP addresses that are used, reserved for multicast communication, if I can say. And these are the numbers you see. 192, something is wrong. Kunoku kuna 01005E, kunoku kuita 192, something is wrong. So for multicast, the range is, I know it's 224000. It should go to 239. Thank you very much. We are with you. Who is that? 239. I was still calculating those numbers in my head. You don't have to cram those numbers, by the way. You can calculate them. It's very easy once you know the ranges. Right, so this is 255. Is it 254 or 255? Okay, let's take down these numbers. It should be 255. All right, so that's the range of multicast IP addresses. So if you see these numbers, automatically in your head, there is a multicast somewhere. And when you say a multicast, we define that as a group of devices that if we want to send information to that group of devices, multicast addresses will be very important. For example, when we are now doing routing protocols. Routing protocols, there is exchange of information between routers only. Not all devices in the network, but the routers only in the network. So that creates a group of devices, the routers. That creates a group of addresses. And if you want to send information to all group of routers, you need to use a multicast address. So multicast address, they're very important. Very important. Because routing, and routing and switching. And yakabatwa group addresses. Why? Multicast addresses. Very important. The MAC addressing table, a layer 2 switch uses layer 2 MAC addresses to make forwarding decisions. It is completely unaware of the protocol being carried in the data portion of the frame, such as the IPv4, ARP, IPv6. The switch makes its forwarding decisions based solely on the layer 2 Ethernet MAC addresses, regardless of whatever protocol is in the upper layers. The data link layer makes its forwarding decisions based on solely the MAC addresses in layer 2. An Ethernet switch examines its MAC addressing table to make a forwarding decision for each frame. Unlike legacy Ethernet hubs that repeat bits out all ports except the incoming port. When a switch is turned on, the MAC MAC address table is empty. The MAC address table is sometimes referred to as the content addressable memory. Right. What is the MAC address table? The MAC address table, I gave an analog of a, a phone directory or mfoni mako inonzi contact contact something. What is it called? Contact list, if I can say. Some contacts. Right. That is the MAC addressing table of the switch. So kana une contact yemunhu uchida kumufonera kungoenda noclicka contact yake direct because it's there in the MAC addressing table. So if you have the destination, you can just go there, auto click or fonera munhu wako because it's there in the MAC addressing table. If it's not, you have to find a number from somewhere or add the number here. Switches are noita if the address is not in the MAC address table, it broadcasts. It sends a message to everyone. Kuti ndinotaura naningi, everyone responds. Not everyone responds, I mean. The one warunotaura naye ningi wacho. If you want to talk to silence, they are no response kuti ndini silence. Nyaya ndei. That's the only difference. Isusu yedu ne-contact list redu hatizoise broadcast. But the switch broadcast, then the correct recipient responds. Everyone else drops the packet, the correct recipient responds. The MAC addressing table. So what we are going to be doing in the next slides is how is the MAC address table built? How is it built? As we switch on the switch, there is no MAC addressing table. There is no entry in the MAC addressing table. But at some point, there will be entries. It will be filled with port numbers and MAC addresses. How does it learn about those port numbers and MAC addresses? Right. Examine the source MAC address lane. Every frame that enters the switch is checked for new information to learn. It does this by examining the source MAC of the frame and the port number where the frame entered the switch. Very important. You definitely get a question like that. You encounter a question like that. What is used to learn MAC addresses in the MAC addressing table? What is used is the source MAC address, not the destination, the source kwabva frame. Ndoma addresses anoiswa mutable iwayo. So if I have, for example, I think the diagram should be there somewhere. Okay, let me create mine. If I have example, a switch, remember ports 1, 2, 3, 4. So this is port number 1. Let's call this port number 1, port number 2, port number 3, and 4. And the MAC address here is A, B, C, D. Before I go any further, you can see switch radio in a former MAC address. I'm sure there is someone who made the assumption that every device it has a unique identifier. Pang one is not one for other devices. If it has multiple NICs, for this one it has multiple ports. It means it has multiple MAC addresses. Irene 4, meaning a 24 port switch, Irene 24 MAC address for those 24 ports. Router Irene 3 former ports, Irene 3 former MAC addresses. Computer yako in a one NIC, in a one MAC address. If it has multiple NICs, then in a multiple MAC addresses as well. Right. So back to our example. How does the switch lane MAC addressing table here issue? No MAC address table. I don't know why I keep saying addressing table. No address table here is empty because switch radio is new. CAM table. Right. The moment A wants to send something to B, what happens? A is a information per port up with the source MAC address being A and the destination MAC address being B. Information panosvika per port E. Switch receives the destination MAC address. Switch looks at the MAC address table. You're empty. It meaning I receive the B in per port tip. So what the switch does, the moment here receiver H, it now adds the source A, the port yava, port number 1. Yamo MAC addressing table, MAC address table. It is length. Do patiri balena. Right. Yashika pano, it broadcasts because there is nothing in the MAC address with B. Paineta broadcast, Panapa will receive, Panapa will receive, Panapa will receive. This one rejects, discards. This one also discards because it's not destined for that PC. This one responds. The moment you know respond at this one, Tane port number 2, pane B, because that's an incoming. Right? That's an incoming frame. That was 0. Then by not just E information E version okuna B zovazapera. That only 2 entries more addressing table. The next time now, pana send information again from A to B. Switch redo a broadcast. Why? Because panosvika information ku switch rinoenderesa kuno rovha ravanoti B iri port number 2, rovha forward directly to port number 2. And that summarizes the process you're switching. Starting with number 1, learning. Learning kuziva kuti port rakati pane MAC address yakati. That is learning. Now we go to forwarding. Yaziva kuti port maports akati ari munetwork yese yaziva. Next time panosendwa information, it directs that information to that specific address. And basically that is how a switch learns and forwards. This is very important, very. This process you're learning and forwarding, you very much need to understand this together. Right, not going into much details, I've already explained the forwarding process. Let's move. Filtering frames. As a switch receives frames from different devices, it is able to populate its MAC address table by examining source MAC addresses of every frame. When the MAC address table of the switch contains the destination MAC, it is able to filter the frame and forward out a single port. We've discussed this already. Kana ma-addresses amo mutable. Instead of sending my broadcast at not my non-unicast, we just send directly to my addresses anenge aripo mutable. Switch speeds and forwarding methods. Frame forwarding methods on Cisco switches. Right, we have mainly two types. Right, two primary frame forwarding methods that are used by switches. Data learning process takuda forward now to the destination port. We have yet not store and forward switching. We have yet not cut through switching. With store and forward, the frame forwarding method receives the entire frame and computes the CRC. If it is valid, the switch looks up the destination MAC address, which determines the outgoing interface. Then the frame is forwarded out the correct port. I'm just going to read, then break it down. With cut through, the frame forwarding method forwards the frame before it is entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. All right. Allow me to stop here so that I can continue. We still have some time, but allow me to stop here so that I can continue, because I think these two ways of forwarding can take a good 10-15 minutes. So allow me to just stop here and continue after.